Good afternoon, all. Welcome to the third week of discussion session of the course Strength of Materials course offered by NPTEL. The course instructor of this course is Professor Shriman Kumar Bhattacharya. He is a professor from IIT Kharagpur. Myself, Asif Raza, I am a PhD scholar from Department of Civil Engineering, IIC Bangalore, and I will be your TA. So we have these discussion sessions weekly on Saturdays 4 to 6. So why how do I keep my discussion session is like in the starting half of this discussion session we'll be discussing questions relevant to assignment number of the current week running. So as of now it's third week, so I'll be discussing questions relevant to third week, and then when we get time we'll discuss questions solutions of assignment 1 and 2 which has already been completed. Okay, so and if you guys feel any doubt, if you have any doubt pertaining to like lectures or today's sessions, you guys can ask me, and you guys are encouraged to like ask your doubts in the discussion forum as much as possible. Okay, so let's start. So the first question for today's session is, so you guys must be knowing static determinacy and all. So question is, which of the following condition represents statical determinacy in a loaded system? And options are when number of unknown forces is equal to number of equilibrium forces. Second option is when the number of unknown forces is greater than number of equilibrium equations. Third is number of unknown forces is less than number of equilibrium equations. And the fourth is number of unknown forces is greater than equal to number of equilibrium equations. So okay, so you guys can give your answer in the chat box as Priyanka has already given. What about others? Uh, Even if you feel that you guys don't know, you guys can like guess, at least guess, so that I may feel like you know or not something about it. Okay, Shiva has also said option A. Yeah, so yes, the correct answer is option A only. This is so statical. Uh, a statically determinate system is the one where the number of unknown forces are equal to the number of equilibrium equations. So okay, let's move on. Okay, let me ask in this further. How do you calculate the statical determinacy for the case of like plane truss, if I may, when you are given with m number of members and j number of joints? So how would you calculate degree of static determinacy? M plus r is equal to 2j. But you're saying m plus r is equal to 2j. Uh, okay, uh, m plus r minus 2j, right? I think you want to write this where r is number of unknowns. Okay, let me elaborate in this. So ds would be calculated uh, using external indeterminacy and internal indeterminacy, and internal uh, static indeterminacy is calculated using m minus 2j minus 3. and external indeterminacy is calculated using r minus 3. So these are kind of like r is number of unknowns and 3 is 3 equilibrium equations we normally have, right? So like in plane truss case, and that is like sigma fx is equal to 0, sigma fy equal to 0, and moment what z equal to 0. Okay, so these are like 3 equilibrium equations for the case of plane truss, and when you add this 2, you'll get ds is equal to m plus r minus 2j. Okay, what about if I just modify this as in 3D space truss? What would be, okay, step by step, what would be DSE?
It will be r minus 6, sir.
Yes, very good. Yeah, it would be R minus 6. And what about internal indeterminacy?
M minus, at the joint, will it be 2 or 3, sir, for
It
3D?
it will be 3. 3j minus
Minus
6.
6.
Yes. So ds would become m plus r minus 3j. Okay. So that is one thing. Okay. So you should like inquire about this, like why there's 2j and why it is 3j here. Right, okay. So let's do a simple thing. Like if we, what is the basic plane truss? Basic plane truss is when we have only this thing, right? Uh, as of now, just leave that thing. This would be the basic plane truss, right? And then like when other members are added. Okay, so at least we need to have 3 members if you would say it. So for this case, if you see, uh, 1, 2, 3. Uh, so 3 members. If I write m minus, okay. So y2j, like each each point or each node is joined by 2 members. Uh, 2 members in this case. Okay. Mm, just let me do it correctly. So I remember that if we want to add additional members, we need to add a, like if one joint is added, so 2 members are added. So that's why like here 2j comes in. Okay, let me say it properly. So this is like the basic. This is the basic one, basic plane truss we have. If we want to like add more, like increase number of members here. So if we want to increase number of members, we need to add a joint itself, right? To have a statically determinate structure. So like if we want to have a one member, we cannot add one member, we need to add at least 2 members, and 2 members would be acquainted with one joint. So like each joint is coming out with 2 members. So that's like if 2 members will be added here, two joint like 2 times of number of joints are there in the system. So that would like make it a statically determinate structure. That's why like in the internal calculation of internal static indeterminacy it comes in. Okay, this is like the simple thing, like R is number of unknowns, minus 3 is number of equilibrium equations present in the system. Okay. Uh, so similarly, like in the space stress, what will happen? Like 1, 2, 3. Okay, this looks proper. So this is kind of a space stress. If we want to add more members to this space stress, what will happen? It will accompany, like if we increase one joint, it would be accommodated with addition of like 1, 2, 3 members, right? So each joint is accompanying 3 members. That's why here it's 3J. Okay, to make the structure statically determinate. Okay, to see whether you guys know about the uh, frames or not, I'll just ask plane frame. Okay, so what would be the case? The plane frames, DS, DSE, DSI, and DS. Plane frames or 2D frames.
TF will be I minus 3C.
Yes, good. DSI. Uh, I
Is
think
it 2M?
actually I have forgotten myself in this. No, it's not 2M though. That's what I recollect. Okay, I actually forgotten myself. I'll see at the end of the session to this. Okay, let's move on to the next question. Uh, so, question is, if it's clear, a question is if a composite bar of steel and copper fixed at both ends, a composite bar of steel and copper fixed at both ends is heated, and it's given that linear expansion of copper is greater than steel, then the copper bar is under, options are compression, tension, shear, torsion. So you guys can give your answers in the chat box of this. So yeah, Shiva and Priyanka has given answer option B. What about Babulal? Okay, I think you guys are wrong in this. So let me elaborate it. So, see, we are given with alpha cu is greater than still, right? Alpha cu is greater than alpha still. Yeah, and if you know in uh, okay, Babulal is also saying B. Okay, let's check whether it's right or wrong. So, uh, in the context of thermal, what would be the strain? So it's like, or I would say elongation, it would be L alpha delta T, right? And uh, for like if I say for copper, L alpha Cu delta T, and for steel, L alpha still delta t would be kind of a normal extension if it happens. So if I see this, uh, delta cu would be greater than delta still, right? Like what would be the normal tendency if both the bodies are allowed to expand freely? Still would be having lesser elongation as compared to copper. But since both are having, it's a composite bar. Okay, let me draw it in a way like, suppose this is copper and this is steel. Okay, steel and this is copper. Okay, so if you see this, uh, this implies that uh, copper would be having, normal tendency would be having that copper will expand more as compared to steel. Okay, but since it's a composite thing, like composite as in like suppose the ends are fixed together, composite bar. So the net that when you increase the temperature, it will have a certain extension such that it is in between this and this. Okay, I hope you're getting, like the extension of the system would be neither this neither this. So if I say delta is what is the extension happening, this is like, okay, this is delta, this is delta cu, and this is delta still. Okay, so delta cu is greater than delta still, but what will happen in the composite thing is, in actuality delta would be lesser than delta cu and delta still. So now if you see, uh, since copper would have extended more if given, if it has been expanded freely, but it is allowed to expand only till delta. Okay, if it would have expanded till delta cu, but it is expanding till delta. So what would like, you are making it like you are compressing it, right? You are not allowing it to extend more, so you are compressing it, so the body will generate compression. Okay, for the copper, while in the case of steel delta still is less than what is already there in the system. Okay, so steel is expanded more as would have it expanded normally. So we are extending it, right? So that's why the steel will develop. So since delta Cu is greater than delta, copper will develop compression, while delta still delta still so still will develop tension. I hope this is clear.
Yes, sir.
Yeah, okay. Thank you for confirmation. Moving on to the next question. You guys can ask anytime, like if you feel that it's not clear. Okay. Next question is, the question is, in a riveted connection for plates, the shear stress in a rivet in double shear will be half to that of a rivet in single shear for the same load. And options are false, true, partially false. In a riveted connection for plate, the shear stress in a rivet in double shear will be half to that of a rivet in single shear for the same load. Same load. Okay, so you guys can uh, give your options. Okay, Shiva is saying partially true. Sorry, partially false. Okay, I would say this and this thing doesn't make sense. Like if I say partially true, the other thing would be kind of partially false as well. So either C, D both or none of them, right? And okay, let me know Shiva's like perspective. Why do you think it's uh, partially false? Aditya has given answer the option B. Okay, Shiva, if you may, or was it just a guess? Yes, Shiva. Am I audible to you?
Yes, sir. So it depends upon the force. If one force is acting more than another plate, no, sir.
No, but in the question it's given that it's the same load, right?
Yes, sir.
Question says same load, and the distinction says in double shear and in single shear. Okay, okay. Let me try to give you the perspective to it. So, shear stress in a rivet in double shear would be uh, what P upon AS, right? Area of shear in acting, like, but in double shear it's actually 2A, while uh, shear stress in a rivet in single shear is just P by A. So if I just see this is sigma 1, this is sigma 2. So sigma 1 is equal to sigma 2 by 2, right? And say double shear will be half that of a rivet in single shear for the same load. So that is what the statement says. So answer would be option B. It's a true statement. Okay. I hope this clears. Let's move on to the next question. Question 4. This is a classic question. Uh, which of the following materials is more elastic than the others? And options are glass, rubber, wood, steel. Okay, I see. Yeah, I thought so that you guys would give answer option B. Okay. Mm, what about Shiva? You haven't given your uh, yes. B only. Okay. If I may ask you all, what do you understand by elastic? If I say a material is elastic, what do you mean by that?
The material which deform and come in original position, sir.
Yes. So if a body deforms, and if we just like if we apply the load, body deforms, and then when we remove the load, it will attain its original configuration, right? So that is what an elastic property implies. So if I say it's as material is more elastic compared to others, uh, what do you imply with that? Like a certain material has a more tendency to attain the original configuration as compared to the others, right? Now, okay, Priyanka has given answer as less stiffness. Uh, Actually, that is quite opposite to it. Uh, okay. Okay. So, elasticity is the property by which a body attains its original configuration when the external force is no longer applied. Okay, and it is given by kind of uh, modulus of elasticity, if you would remember. So, modulus of elasticity is given by the ratio of uh, stress, roughly I am saying, stress upon strain, or longitudinal stress upon longitudinal strain. Okay, just write it. Or just simply stress upon strain if you are not knowing. So uh, this is given by what? E upon sigma epsilon, right? This is this thing you must be you must be knowing. Like okay, okay. Now, if you would know, like if you study subjects like, or go through the literatures, you would find the uh, E, Young's modulus. If you would know, the other name for the modulus of elasticity is, if you compare all the four, yeah, Young's modulus or modulus of elasticity of steel is greater than the rest. Okay, even greater than the rubber. So steel has a tendency to attain its original configuration more as compared to rubber. And to give more insight to this, it's like if you uh, draw stress versus strain plot, you must be knowing this, something like this. Okay, so this slope is what is the uh, modulus of elasticity. So uh, this implies uh, this implies like if E is greater than, it implies that just for a little deformation in the system, just for a little deformation in the system, body has a large tendency to develop the stresses. So if the body is developing a large amount of stress, that implies that it has more stiffness pertaining to it, and it is more elastic. And since it's developing stress, why does it develop stress? Because it is not allowing the body to go to a different configuration. It is making the system to attain closer towards the original configuration. Then only the stress would develop. If I ask you, like suppose this is a system, okay, this is one system, this is other system. Okay, now this is, both cases are like a bar thing. Both here only one side of the uh, bar is fixed, while here both sides of the bars are fixed. Okay, now if I increase the temperature by delta T in both, like what kind of stresses will develop in both the system? Can you guys let me know? Like system A, this is system A, system B. If I ask you, like in both the system, I increase the temperature by delta T, and both having the same materials. So what kind of stresses will develop in system A and system B? Yes. What about in B? I increase the temperature. Okay. Yes. So you're quite correct. System A will develop uh, no stress, and it will develop compressive stress. So here the body is deforming, right? But it won't attain its original configuration until and unless the temperature. Okay, it's digressing. We are digressing from the original discussion, but it's okay. Uh, since this system is allowed to expand freely, no stress would develop, while in the system we are restricting it not to expand. So the body will generate compressive stress. Okay. The thing is, for this question, you should remember that the Young's modulus of elasticity is the governing factor to it, like which body would be more elastic. So higher the Young's modulus of elasticity, higher would be the body is having more elastic. A body is more elastic in nature. Okay, so if I ask you pertaining to this, what is uh, if E steel and E aluminium, which one of them is are more elastic in nature compared to these two? Which one is more elastic? Yes, yes, Pinky has given answer as steel. So yes, steel is more elastic. Steel you should be knowing, it's a general sorry, standard. So it has like 2 into 10 to the power 5 GPA, no, MPa. Yes, okay, or more properly 2.1 into 10 power 5 MPa. Okay, let's move further. I hope this is clear for you all. Let's move on to the next question. Question number 5. Okay, this is kind of given in the assignment also. So let's see. So question is, a brass specimen of 15 diameter is subjected to a tensile pull using a gauge length of 50 mm. When the tensile load reaches a value of 50 kN, the distance between the gauge marks increases by 0.1 mm. What would be the modulus of elasticity of brass? And the options are given. Okay, so directly asking you guys to give the answer, it would be best to take a step by step. So I would ask you all, what's the uh, what would be your workaround with this question? How would you solve it? Can any one of you feel confident to unmute yourself and let me know? We are given with the uh, answers data as 15 mm diameter, uh, gauge length as 50 mm, tensile load P as 50 kilonewton, and delta or increases by 0.1 mm. Okay, yeah, anyone?
So using formula,
Yeah, what would be that?
deformation is equal to PL by AE.
Yes, okay. So in this question, P is already given, L is already given. What about A?
Given, sir.
Yeah, it's like
Diameter
pi by
given.
4 d square. We are given with the diameter. So E. Okay, so that would be the E would be PL pi by 4 d square times delta. Now you should be careful with the uh, what you say, with the units. Okay, so what normally I keep everything in terms of Newton, and force unit as Newton, and length units as in mm, and the stress units in MPa. So I'll convert this. This would be 50 into 10 to the power 3 Newton, while others are in mm only. So let's do this. 50 into 10 to the power 3. Length is 50 mm upon pi by 4 d square is 15 square into 15. So let me check it.
Let it C, sir, option.
Okay, saying option C. Let me do it myself also. 50 into 4 and yes, so yeah, answer comes out to be 41.47 into 10 to the power 3 MPa. Okay, this is in MPa since it's a stress unit, it's an MPa. And if you see in the question, its units are in GPa, so we'll convert this. So this would be equal to 141.47 GPa as 10 to the power 3 MPa is equal to 1 GPa gigapascal. Okay, answer is C, option C, 141.47 GPa. Okay, let's move on to the next question. So question number 6. So this is, seeing the question, it feels like it would be a tough one. Let's see. It's a easy question. You just need to see what all the data has been provided. So let's see. Question is, an artificial rubber pad of thickness T equal to 50 mm is bonded with two steel plates as shown in the figure. The pad has dimension A equal to B equal to 100 mm. When the top plate is subjected to a shear force of equal to 10 kN, the rubber pad displaces by 1 mm relative to the bottom of the plate. The shear modulus of elasticity of the artificial rubber is, and the options are this. So I'll give you guys time to work this around, and let me know what is the correct answer for you all. Okay, rather let's do it step by step. I'll ask you guys what are the answers and step by step. So we need to find modulus of elasticity, right? This is what we want to find. In general setting, it is denoted by G. Okay, so what is the shear modulus of elasticity? Now, for that, to calculate, we need to have shear stress upon shear strain. Now, shear stress, uh, let me first draw this kind of initially. We are given with this system. Okay, uh, this is the displacement. So after, like, this is fixed in the term, so after certain displacement it moves to a different position, kind of like this. Okay, uh, so what would be the shear stress? Shear stress would be shear load upon on the area on which it is applied, and that would be equal to V upon AB. Okay, and V is, okay, we should first write the data which are provided. So V is given in, okay, let me first note this. um, so what all data has been given, let us write those things. So we are given with the force 10 kilonewton, that is 10 to the power 4 newton. Then A equal to B equal to 100 mm, and thickness as 50 mm, while the displacement has been provided as delta as 1 mm. Okay, now uh, so what would be the shear stress? V upon AB. Okay, and okay, Priyanka has already given answer. Let's see if it comes to that only. So V is 10 to the power 4, A is 100, B is also 100. So this is like 1 MPa. Yeah, isn't it? 10 to the power 4 Newton per mm square. Yeah, and what would be the shear strength? shear strain is, there is a delta displacement here, and this is thickness. So shear strain would be delta upon T, and that is delta upon T, that is 1 upon 50, and this would be having, this is a dimensionless quantity. So now uh, using the formula for the shear modulus of elasticity, it would be equal to 1 upon 1 upon 50, and this would be equal to 50 MPa. Okay, and that is what Pink has also given the answer as D. So I think this is quite clear. In this thing, you just need to see that where the shear stress, how is it acting, and what would be the shear strain. So shear strain is the amount of rotation it is creating. Okay, so that is delta upon T. Okay, let's move on to the next question. Question number 7. Question number 7. So question is, the temperature of a 2-meter long copper rod is raised from 20 degrees Celsius to 75 degrees Celsius. Determine the stress in the rod if it is fixed at both ends. And the values are already provided. So this is quite a simple question. I would ask you all to like solve it and give your answers. I would ask you all the three, whoever is present, Shiva, Babu, and Priyanka, to give your answers what you felt. Meanwhile, I'll just write all the data provided here. So length I is 2 meter, that is 2002 into 10 to the power 3 mm. Then Young's modulus is 10 to the power 5 MPa. Alpha is 18 into 10 to the power minus 6 per degree Celsius, and if I say T1 is 20 degrees Celsius and T2 is 75 degrees Celsius. Okay, so Priyanka has already given the answer option A. What about Shiva? Uh, you can like unmute yourself, rather if you haven't solved, you just let me know how would you pursue this question. You need to find the stress in the rod if it is fixed at both ends. No idea. Okay, no problem. Okay, so uh, so you can see what all data is already provided. Okay, you have no issues regarding this. I hope. So these are all the data is provided. Now, since the system is raised from 20 degrees Celsius to 75 degrees Celsius, that implies like change in the temperature, T2 minus T1, that is 75 minus 20, and that is 55 degrees Celsius. Okay, now we need to find the stress. Okay, so you know that modulus of elasticity is equal to what? Stress upon strain. Okay, I'll write in a short notation that EC is upon sigma upon epsilon. Okay, where sigma represents stress, strain represents is represented by epsilon, and we need to find the stress. So sigma is equal to EC times epsilon. Okay, now epsilon is what? The strain for in the context of thermal expansion, it is equal to L alpha delta T. No, L alpha delta T, only alpha delta T. Okay, this is the strain present in the system because elongation due to temperature extension is L alpha delta T and epsilon is delta upon L, so that would be like alpha delta T. So this would imply stress present in the system would be sigma would be equal to EC times alpha delta T, that is equal to EC is given as 10 to the power 5, MPa alpha is 18 into 10 to the power minus 6, and this would be equal to 55. So 55 times 18, that is like 990 into 10 to the power minus 1, and this is in MPa, and this is equal to 99 MPa. So this is the answer. Okay, Priyanka gave answer as option A, and that is quite correct. Option A is the answer. So Shiva, I hope you got the idea. Why is it so? Due to temperature, the extension in the body is given by this. First thing, how would you find the modulus of elasticity? It's a ratio of stress upon strain, and we need to find the stress. So, and modulus of elasticity is already given. You need to find what would be the strain in the body, and strain is equal to change in the length of the system in consideration upon the original length, and for the temperature, for thermal expansion, it's given by L alpha delta T is it's what's the elongation of the system. So L alpha delta T upon L would be the strain present in the system. That is alpha delta T. You just substitute everything and you'll get it. 99 megapascal is the answer for this question. Okay. Uh, I hope it's clear. Moving on to the next question now. Question number 8. The question is, in the figures shown below, a cable BD of diameter 20 mm supports a steel girder AC subjected to a load 100 kN load at end C. The tensile stress in the cable is. So I don't think. Okay, I'll give you guys time to this. What would be the tensile stress in the system when you're given with the diameter of the cable, and we are saying the 100 kilonewton load is applied at the end C? Okay, rather waiting, I should solve this then. Okay. Meanwhile, you guys keep doing if you are doing, whoever is doing. So let us assume that tension T is present in the cable. Okay. So let's draw the FBD pertaining to this. So we are given with the beam where 100 kilonewton is applied here, and from here to here is a cable attached to it. Okay, so let's say tension T is present here. Okay, and the load here is 100 kilonewton, and we are given with 9 meter here, 12 meter here, 4 meter here. Okay, now first thing first, let us resolve the, we need to find what would be the tension T, right? To find the stress in the cable, we just need to find the tension T present in the cable, and then stress would be what? Stress would be equal to load upon area, and in this case it would be T upon pi by 4 d square, right? T upon A, that is T upon pi by 4 d square. In the question given, we are given with the question as D is 20 mm. Okay, so everything lies how will we find this tension T. Okay, let's try to solve it. So okay, now if I resolve this tension T, if I resolve this tensile T in the horizontal and the vertical direction, so kind of if I write this TV and T horizontal, so what would be TV? It would be if I say this as theta, so TV would be T sine theta, and TH would be T cos theta. Okay, and what would be cos theta? Cos theta would be equal to the base 12 upon the hypotenuse, that would be 12 square plus 9 square. Okay, and that is equal to 12 upon root, this is 144 plus 36, uh, the critic root of 180. Okay, so let us take it as root 180 only, don't mess it up, and sine theta would be equal to 9 upon root 180. Okay, so this implies TV equal to T times 9 upon root 180, and TH would be T times cos theta is 12 upon root 180.
Sir,
Yeah.
sir, I think,
Okay, okay. Got it. Yeah, it would be 81. I think that's what you were saying, right?
yes, sir.
Okay. So this would be root 225, and that is 12 upon 15. 12 upon 15, and that would be like 4 upon 5. So sine theta would be 3 by 5. Okay, so I'll just correct this thing. Thank you. So TV is 3t by 5 and th is 4t by 5. Okay, now what would be this t value? So to find this, we need to see. Okay, so if I see the system, like this is the body, this is the system, right? So what kind of reactions would be developing? The reactions would be present here and here, right? Like uh, reactions that would be uh, that will be present in the system, and we just need to find what is the t. So if you see, okay, let me write this. If I write this here, it was A, B, C, and D. So I write it, the reactions develop at R, A, R, D. Right? This will be the reactions developed. Now, if I don't want to find R, A, R, D, I just want to find D. Oh, sorry, T, right? Okay. So let us take these are the things we have found. So let us take sigma fx equal to 0, sigma fy equal to 0. Let us just use these two things. So sigma fx is Ra plus Rd equal to, it would be equal to Th. Okay, and maybe Th equal to 0, and sigma fy would be equal to uh, TV minus 100 kilonewton, it's equal to 0. Okay, since vertically only TV is acting on the load applied. So if we are not interested to find in the reaction forces, we can just work around with this. So TV is equal to 100 kilonewton, and TV is 3t by 5 and equals to 100. This implies T is 500 upon 3 kilonewton. Okay. Yeah. Now, if I may, 5t upon 3, right? Yes. Now,
Sir,
yeah.
uh, I like I try to find t using the moment method, taking moment at a.
So with that, RD would also be there, right?
No, sir.
If you see,
I took only the rod as the free body, like that girder as the free body diagram.
okay, I got it. So you're saying uh, you took this system R D, right? Oh, sorry, RA, and the applied load T as this thing. So kind of TV and TH, and the load applied here 100 kilonewton. Mm, so this would also give me TV equal to 500 upon 3, right? T is equal to 500 upon 3.
I got different answers.
No, okay. So you're saying if you are taking with the moment, this is equal to 12 and this is equal to 4. 12, 4 and mm, okay. Okay, I got it. What am I doing? Okay, so see, this when I like if I take RARD thing, this tension T, it would be kind of an internal force, so that I shouldn't bring it up for the calculation. Like what am I doing? The mistake is uh, I am taking I was taking this. So if I'm taking R D and RA, the only external load applied is here, right? P I should write. So with this only I should try to find like what will be uh, the forces being generated in the system, like tension T present in the cable. But since I'm trying to like I have taken T as here, kind of I am taking only this as the system. Okay, so uh, this would be kind of so tension T, that would be resolved to TV TH, and say we are not showing here, here it's a connected thing something, so kind of a reaction will be generated here also. Okay, since we are cutting here, so let us take it R and here as RA and here as P. That's why like if I take some sigma Fy equal to 0, that is also not coming out to be the same. If it had been uh, okay, so that's why now if we take a moment about this A, this as B and this as C. Okay, so thank you, Priyanka. So this is a mistake. So this is a so moment about A equal to 0. So if I take moment about a RA, R, TH would be gone. There won't have any effect. Only T and TV and P would have effects, and that is TV. This is 12 meter, and this is 4 meter, right? So TV times R P P times 12 for 16 minus TV times 12, it's equal to 0, and TV would be equal to 16p by 12, that is 4p by 3, and TV is 3t by 5, 4p by 3 implies T is equal to 4 5 20 p upon 9. So that is 20 into 10 to the power 100 kilonewton. Okay, so 20 into 100 kilonewton by 3, and this would be equal to 2000 upon 3 kilonewton. Okay, and if I want to take it in Newton, so it would be kind of 2 to the power 2 by 3 into 10 power 6 Newton. Now, uh, let us find the stress. Let us find the stress, and that would be equal to T upon A, that is 2 by 3 into 10 power 6 pi by 4 d square. D was given as 20 square, that would be equal to, so 2 divided by 3 into 4 divided by 5 divided by 4.
Sir,
Yeah, yeah,
sir, like while writing from from 9 it became 3, sir.
this
T
one.
is equal to 20, no, down one, sir. T is equal to 20 P by 9 is equal to.
Oh, okay. Okay, thank you. I'm making a lot of mistake now. 2000 upon 9, 2 upon 9, 2 upon 9. Okay, let me at least do the calculations correctly. 2 upon 9 into 4 divided by 5 divided by 2. So it's around 707.355 MPa, right? I hope this is the calculation is correct now. So, this is the answer would be option C. I hope that is okay for you all. Uh,
Yes, sir.
yeah, I made a mess in this question. Okay, thanks for helping me out. Let's move on to the next question. Question 9. Okay, so question is, uh, figure shows forces acting in a stepped cantilever bar fixed at the right end. If the bar is subjected to 2000 kilonewton load on the left hand as shown in the figure, total deformation of the bar is, and even E2 E3 is given values are 200 GPa, while the stepped cantilever is provided in this figure. So I would give you guys time a bit to solve this. Meanwhile, I'll just solve this thing myself also. So for this, let me draw this. A3, L3, A2, L2, A1, L1, and we are given with the load P, say, and if I just write it E1, E2, E3. Okay, so for this case, since the deformations would be cumulative in nature, and you know the formula for the deformation or elongation, it is equal to what? PL upon AE, right? And so if I just write it for for each stepped cantilever, what would be the deformations? So it would be P L1 A1 E1 delta 2 is P2, L2, P2 is P only, A to E2, and delta 3 is PL3, A3, E3. Okay, and so net change in the length, total deformation would be equal to delta 1 plus delta 2 plus delta 3. That would be equal to P L1 A1 E1 plus L2 A2 E2 plus L3 A3 E3. So this is pertaining to the case where only P is applied. If there had been, like, suppose here value say P3, so here it would be kind of P3. Okay, you need to balance like what amount of force is acting for that step continuum. Okay, so PL3 E3. For the given question E1 E2 E3, it's equal, so I'll just take everything out and just write we're given with E1 E2 E3, taking out is E, so this would be equal to L1 upon A1 plus L2 upon A2 plus L3 upon A3. Okay, now P is 2000 kilonewton. Okay, so if I write it into Newton, it would be kind of 2 into 10 power 6 Newton. E is 200 GPa. Okay, should write it. I'll just remember this thing. So in the question, we are given with P as 2000 kilonewton. That would be equal to 2 into the power 6 Newton. E is given as 200 GPa. So this would be equal to 200 into 10 to the power 3 MPa. That is 2 into 10 to the power 5 MPa, omega Pascal. Now L1 is 100 mm. L2 is 160 mm. L3 is 75 mm. Then A1 is 10 mm square. A2 is 20 mm square. A3 is 15 mm square. So now we'll just substitute everything in the formula, and that is 2 into 10 power 6 upon 2 into 10 to the power 5. L1 is 100 upon A1 is 10. L2 is 160 upon 20. L3 is 75 upon 15. So this is 10, this is 10, this is 8, and this is 5. So 10 plus 8, 18, 520, 230, and unit would be in mm. Okay, so you guys better check the units properly. So 230 mm. Right. Somewhere again I made a mistake about 2000 kilonewton. That would be 2 into the power 10 power 6, 200 GPa, and that is 200 and 10 power 3 MPa, that is 20 10 power 5.
Let me process.
Okay, yes. So I think so these all must be in meter only then. Either these things would be in meter, or uh, else like it would should be multiplied with 10 power 3 to get in mm. Okay, so I hope the procedure is okay with you all, like how would we find it. So with that, the answer would be option C, 0.23 meter or 230 mm. Okay. Okay, thanks for confirmations. Let's move on to the next question. Question number 10 for today's session. Okay, uh, so it's a slightly big question. So let's do it. Question is a steel rod of 30 mm diameter is enclosed centrally within a copper tube of external and internal diameter 50 mm and 40 mm respectively, as shown in the figure. The temperature of the composite bar is raised by 100 degrees Celsius if length of steel rod and copper tube is 150 mm. Stress generated in steel rod and copper tube are, and we are given with the Young's modulus and coefficient of linear expansion for both the components. So uh, rather let me know the type of stress also in each copper and steel, right? So let's do it. So let's first write it down. So we are given with the diameter of steel as 30 mm, okay, and diameter of copper external copper external as 50 mm and diameter of copper internal as 40 mm. Okay, so if I ask you what would be the area of the copper, it would be equal to pi by 4 uh, dCUE square minus dCUI square. Okay, and for this area of steel would be equal to pi by 4 ds square. So this would be equal to pi by 4 30 square whole square. This would be equal to pi by 4 and 50 square minus 40 square and square, that would be equal to pi by 4 uh, 900 mm square. Okay, now we just found one thing. Next thing is, okay, so temperature raised in the system is delta T is 100 degrees Celsius. Hmm. Length of steel rod and so length of steel rod, length of copper is given as 150 mm and Young's modulus of steel is 2 into 10 to the power 5 MPa and AC is 10 to the power 5 MPa only. Alpha steel, let's write alpha S is 12 into 10 to the power 6 per degree Celsius and alpha C is as 18 into 10 power 6, 10 minus 6 per day Celsius. Okay, now let's see what will happen. As I uh, told you earlier, if you see alpha s, or normal tendency for the expansion would have been for the still L alpha Cu delta T. Since L and delta T is same, so we would compare with alpha Cu, right? So alpha Cu L alpha S delta T. Okay. Now the okay, so alpha Cu is greater than alpha S, that would imply extension in the still would be greater than delta Cu. If they were allowed to expand freely. Okay. Now, mm, uh, but uh, so okay, here I'm making a mistake. Delta Cu would be greater than delta S. But since it's a composite thing, copper would be allowed to would experience a compressive stress. It won't be allowed to expand freely, and still, since it is having an lesser coefficient of thermal expansion, it will elongate a bit less. But because of composite in nature, they would be allowed still would be forced to elongate a bit more. So uh, exact extension would be kind of, it would be between this. Okay, now let's see how would we calculate what would be the natural or I should say what would be the actual stresses in the system. So first thing, uh, mm, that delta for both like net in actual thing, the deformation would be same. Like these were like if they were allowed to expand freely. Now when they had a composite system, so if I would write like delta Cu and delta still, where delta Cu is equal to delta and delta S is equal to delta. Okay, and it would include what uh, since copper had a more extension, but it was made to compress a bit. Okay, so kind of uh, first thing, it would have extended del alpha Cu delta T. Okay, so this would have been a free expansion, but it was allowed to compress a bit. And compression, how much compression will happen, this would be calculated by sigma C upon AC times L. Okay, sigma C upon AC would give me uh, sigma C upon AC. This would be give me the strain times the length. So this would be kind of the compressive strain developing in the copper, and that would be kind of, let's substitute it, sigma C upon AC and times length, and Cu. Similarly, in the steel, it was a lot to extend a bit. Now, steel was forced to extend a bit, so tensile stress would be acting on that, and this would be equal to sigma S upon AS times L. AS not ES. Okay. and L is common all throughout, so I'll just write alpha Cu delta T uh, minus sigma Cu upon ECU alpha S delta T plus sigma S ES. Okay. Now if you see, there are two unknowns here. One is sigma Cu, sigma S. We know all other things. So this won't solve the question completely. So you need to get one more equation for this. So other equation will be what ki the load acting, since the system would be in equilibrium, the load acting on both the copper and steel, it should be one and the same. That means the compressive load uh, on copper would be equal to tensile load on steel, right? And load would be given by sigma Cu times ACU, and tensile load on steel would be equal to sigma S times AS. Okay, so this is the other equation which we need to use it. So I'll just substitute this. Okay, so sigma Cu is equal to sigma S AS upon ACU. Just substitute in the previous equation 1 and 2, put 2 in 1. So that would give me alpha Cu delta T minus sigma Cu is sigma S AS upon ACU equal to alpha S delta T plus sigma S ES uh, ACU times ECU. So let's take sigma S in one side. So alpha Cu delta T minus alpha S delta T, write it completely. Alpha Cu minus alpha S delta T is equal to sigma S upon ES plus sigma S AS ACU ECU. Okay. So sigma S would be equal to uh, 1 upon ES plus AS ECU ACU 1 upon alpha Cu minus alpha S delta T. Okay, let's substitute everything here. Sigma S 1 upon ES is 2 into 10 to the power 5 plus AS pi by 430 square. So AS upon ACU, right? AS upon ACU would be equal to 3, it would be equal to 1, right? Yes. So AS upon ACU is equal to 1. 1 upon ECU. ECU is 10 to the power 5. Alpha Cu minus alpha S. 18 minus 12. 6 into 10 power 6. And delta T is 100. Yeah. 100. So this would be equal to 1 by 2 plus,
Ankit,
yeah,
AS upon ECU.
AS, yes, AS upon ACU would be equal to 1. pi by 4 ds square, pi by 4 times 900, and this was also pi by 4 times 900. So as upon acu is equal to 1.
Sorry, sir. Sorry, my mistake.
Yeah, no problem. Okay, so let's see. So this would be 1 by 2 plus 1. So that would be equal to 3 by 2. So 3 by 2 into 10 to the power. So 3 by 2 into 10 to the power 5 times. If I take this in the numerator, so 6 into the power 10 power 2, and 3 to 1 by 4.25 times 1 10 to the power minus 1 0.025. Let me see. 3 by 2. Yes. Or again I made a mistake or what? Okay, let's solve it. So if I take 10 to the power 5 as common, 1 by 2 plus 1, and this is 6 into 10 to the power minus 4, so 3 by 2 into 10 to the power minus 5, 6 into 10 to the power minus 4, and 3 to 1 by 4 times 10 to the power minus 1.25 into 10 to the power minus 1, that is 0.025. Right, this should come, but I think something is wrong. 30 is steel rod, external copper tube is this, so pi by 4 50 minus this, so this one is okay, so this is okay, this is okay, this okay. This thing is also okay. No substitution. Did I make a mistake here? Wrong. Sigma cu upon ECU. ECU is okay. Alpha S sigma cu times ACU. So this is okay. Then 1 upon Cu plus 1 upon S alpha Cu minus substitution I'm making is correct only. Six into 10 to the power minus 4 sigma C 10 to the power minus 5. Let's see. So kind of 1 by 2 plus this, so 3 by 2, right? 1.5 and divided by 6. Yeah, this is only coming, right? You're saying Priyanka is saying stress of copper and steel both should be 40 MPa. sigma c 1 by 2 plus 0.5 1.5.
Push it up. Push it up.
Mm, okay, I got my mistake now. Yeah, the thing, skipping the guns is what makes mistake. Okay, let's do it step by step. So I'll take common here, sigma s as 1 upon es plus sigma uh, as upon ecu acu. So this is alpha cu minus alpha s delta t. Sigma s would be equal to I got my mistake. So this is 1 upon es plus as ecu acu. Okay. Since as is equal to acu, we'll just substitute everything. So this is 18 minus 12 10 to 10 power minus 6 times 100 divided by 1 upon es, that is 20 to 10 power 5, plus as upon acu is equal to 1, and acu is 10 to the power 5, and this is 6 into 10 power minus 4. This will give me 3 by 2 into 10 power minus 5, and that would be equal to, so 60 120 upon 3, that is 40 MPa. Now from to sigma cu, this is sigma state, sigma cu would be equal to sigma s as upon acu, and as upon acu is equal to 1, so this would be equal to 40 MPa. So with sign, if I write, both would be kind of 40 megapascal. So with sign, if I write in the steel, it would be compressive stress, so kind of 40 megapascal, while in the copper it would be kind of minus 40 megapascal. Okay. Today I'm making a lot of calculation mistakes, so it's better to wind it up soon. Okay, so let's move on to the next question. Question number question question number 11. So question number 11 says a pin jointed tongue holds a block weighing 75 kilonewton as shown in the figure. The coefficient of friction at the gripping surface is 0.1. Assuming that the force is applied along x-axis and the block is gripped along y-y, then the force F required to hold 75 kilonewton weight is, assume the pin joint is frictionless. So since the time is very less, I'll try to solve it myself. Okay, we need to find, we are given with the weight of the block W as 75 kilonewton. The coefficient of friction at the gripping surface is 0.1. So mu is given as 0.1, assuming that the force is applied along x-axis. So this is the force applied, right? Okay, force applied is here, and the block is gripped along y here, and the force F is equal to hold 75 kilonewton. So we are given with F value as 75 kilonewton. Okay, so mm, mm, so kind of uh, F y. Mm, okay, so let's solve it. They are given with the force F. Oh, F is not given. We need to find F. Okay, so let's try to solve it. So we're given with the system, and here is the block, right? The blue. Now what will happen is we'll get a normal here, and force F is applied here. Okay, uh, we are given with this as 25, this one as 75 mm. Okay, now uh, uh, mm, what should be the force in or should I say what should be the n? What should be n first? So n would be, or since friction is acting at this y, right? This is y, x. The friction acts only at this point, while force we are applying is here. So we know, if you know, friction force Fs is given by mu times normal. Okay, and the friction force would be acting here, kind of like this, Fs. Okay, and uh, so if I write Fs both as a cumulative thing, so Fs would be equal to mu times normal, and this should be equal to the weight of this block. So W is 75 kilonewton, mu is given as 0.1, so normal would come out to be 750 kilonewton. Okay, now uh, we need to find what would the force F. Okay, and this Fs is equal to uh, kind of Fs plus Fs. Okay, if you means and this is kind of mu n I'm saying, but uh, I mean to say 750 kilonewton normal would be acting, but it would be divided into the two systems, and if I consider only the one half of the system, say uh, symmetry of the system, so kind of this 750 kilonewton is to be applied in both of this combined system. Okay, so if I consider only first half, only one of the halves, so kind of normal would be equal to 750 by 2, that would be kind of 375 kilonewton. Okay, so rather I should write it okay, I should write it Fs plus Fs is equal to mu n times mu n, that is 2 mu n. Okay, and this Fs plus Fs should resist the force W, so that would be 2 mu n, and n would be equal to W upon 2 mu, that is 75 by 2 into zero point 0.1 kilonewton, that is 375 kilonewton. Okay, so normal is 375 kilonewton, and if I consider the symmetry of the system, since I don't need to take complete system, and I need to find what would be F, right? So I take the moment about O, if it is not named. Okay, I'll try to take a moment about O, So if I take, when I have taken symmetry into effect, so F is acting here and normal is acting here, and the distance is 75 mm here and 25 mm here. So moment about O equal to 0, this would be equal to F times 75 equals to normal times 25, and F would be equal to n into 25 by 75, that is n by 3, and normal came out to be 375 kilonewton. So this, and this is 3125 force. So I think this is one. Yeah, so answer would be option A, 125 kilonewton. I hope it's clear for you all. Friction would act on the both surface, and friction force is equal to mu times normal. So mu times normal for both, it would be kind of 2 mu normal, and this friction force should resist the weight, uh, and with that we'll be able to get the normal, and then we'll use the moment equilibrium equation to, with the consideration of the symmetry of the system, we'll be able to find the force acting on the system, like what amount of force we need to apply in the holding section or the along x-axis to resist the load along y. Okay, I hope it's clear for you all. So let's move on to the last question for today's session, and question number 12. So it's a question similar to the assignment. The question is, a 25-meter long aluminum pipe is placed adjacent to a steel pipe 25.02 meter long at 20 degrees Celsius. At what temperature will the aluminum pipe be 15 mm longer than the steel pipe? A 25-meter long aluminum pipe is placed adjacent to a steel pipe 25.02 mm long at 20 degrees Celsius. At what temperature will the aluminum pipe be 15 mm longer than the steel pipe? So, okay, so let's do this. So we are given with the condition at 20 degrees Celsius, length of aluminium We'll write it L A L L A as 25 meter, and length of steel pipe LS as 25.02 meter. Okay. Uh, then we need to find at what temperature, at what T, T equal to what, length of aluminium La, uh, uh, if I take final length of L is equal to La, and final length of uh, steel as Ls. So condition is uh, that La, what temperature of the aluminum pipe B, La would be equal to Ls plus 15 mm. So this is given, we need to find what is the temperature. So let us convert this into mm. This would be 25,000 mm, and this would be 25020 mm. Okay. Now let's use this. So La plus uh, La Ls La equal to Ls plus 15, and what would be La? La would be L alpha delta T, or La alpha A, La alpha A delta T, and Ls would be Ls alpha S delta T plus 15, and La is given as 20 to 25.
So,
Yeah.
for LE is equal to LB plus 15, we should also add LA and LS also.
Uh,
L alpha delta T will give the deformation.
okay, okay, yeah, yeah. Nice, nice. Thank you. La and Ls. Yes. So 25,000 plus 25,000. Alpha A is 23 into 10 minus 6. So if I take this temperature as T, so delta T would be T minus 20, and this should be equal to Ls is 250 25020 plus 25020 into steel has 12 to 10 power minus 6 written uh, into T minus 20 and plus 15. So let's solve this. Okay. So T minus 20, taking it common, so 25,000 into 23 into 10 power minus 6 minus 25020 into 12 into 10 power minus 6. Now other thing, 25020 plus 15 minus 25,000 implies T minus 20. This would be equal to 25,000 into 23 minus 25020 to 2. So this is kind of 0.274 7 6 equal to 20 plus 15 35. T minus 20, so 35 divided by 0.24274. 35 divided by 0.27476 and plus 20, 147.138. So this is 127.383. This implies final temperature would be equal to 147.383 degrees Celsius. So this is the answer, and yeah, final answer is option B. Okay, it's almost like only the questions of assignment 3 took all the complete 2 hours. Okay, so this completes discussion session for today's uh, week, current week. If you guys have any doubt like pertaining to any lectures or today's session, you guys can ask. Or else we'll meet on the next weekend, same time, Saturday 4 to 6, and we'll be discussing questions relevant to assignment number 4, and if the time persists we'll discuss the solution for previous assignment as well. And I'd like to thank Priyanka for helping me a lot in this. Okay, thanks. Anyone has questions? So can we wrap up today's session? Can anybody give affirmation? I think a lot of questions has been discussed which would help you all to solve the assignment problem, and the gist is in the assignment for the current week pertains to thermal expansion. So L alpha delta T is what is the elongation, and E alpha delta T is the thermal stress. So can we wrap up? It's almost 2 hours, 6:10. Okay, Siva, thanks for joining. Others, can you give affirmation that shall we close?
Yes, sir. Thank you, sir.
Thank you a lot for joining. See you next weekend, same time, 4 to 6. Okay, bye. Take care. Have a nice day all. Yeah, you're welcome. Bye all. Bye. Take care.